We use them for everything, right? From firing off a quick email to exploring entire virtual worlds. But have you ever really stopped and wondered how a computer actually works? Well, today we're pulling back the curtain. We're going to break down the core ideas that power our digital lives, starting with the absolute basics that are just as important today as they were decades ago. So, let's dive in.
It can totally feel like magic, can it? But here's the secret, it's not. It's just a system of really brilliant, logical steps, one after the other. And I promise, by the end of this, you'll get the key principles that make it all happen.
Okay, so at the highest possible level, every single computer is really just a team of two. You've got the hardware, that's the physical stuff you can actually touch. The monitor, the keyboard, all the little chips and wires inside. And then you have the software. That's all the invisible instructions, the programs that tell the hardware what to do. To really understand how it all works together, we've got to start with the physical machine.
To make sense of what's going on inside that box, we're going to use an analogy that's actually super helpful: the human body. So let's take a look at the computer's brain and its nervous system.
The foundation of pretty much everything is the motherboard. If a computer was a person, this is the central nervous system. Now, it's not doing any of the thinking itself. Its one absolutely critical job is to connect everything else. The brain, the memory, the storage, they all plug into the motherboard so they can talk to each other. Without it, you'd just have a box full of really smart parts that can't communicate.
And plugged right into that motherboard is the undisputed brain of the whole operation, the CPU, which stands for Central Processing Unit. This thing is the engine. Every single command, from just moving your mouse across the screen to loading a complicated web page, all of it ultimately breaks down into a series of calculations and instructions that have to be processed right here. This is where the real power and speed of a computer comes from.
So, what does this brain actually do all day? Well, it just runs a constant, ridiculously fast three-step cycle, over and over. First, it fetches an instruction from memory. It grabs the next item on its to-do list. Second, it decodes that instruction to figure out what it's being asked to do. Add these two numbers or move this chunk of data. And finally, it executes the operation. It just does the thing. Fetch, decode, execute. And it does this billions of times per second. It's incredible.
So, what are these instructions we're talking about? Well, they're not written in a way that you or I could easily understand. See, writing directly for the CPU is insanely complicated. So instead, programmers use what are called high-level languages, things like Python or JavaScript, which are designed to be much more readable for us humans. But that creates a bit of a problem. How does the CPU understand our language?
That is the job of a very special program called a compiler. You can think of a compiler as a translator. It takes our human-readable high-level code and converts it into low-level machine code. And what is machine code? It's just a long series of ones and zeros, also known as binary. That's it. That's the only language the CPU actually understands.
Okay, so we just mentioned that the CPU fetches instructions from memory. But what even is memory? Well, it turns out that computers have two main kinds of memory, and they work a lot like our own short-term and long-term memory.
First up, we've got RAM, or random access memory. This is the computer's super-fast short-term memory. The whole point of RAM is speed. When you open a program or a file, all the data that's needed gets pulled into RAM so the CPU can get to it almost instantly. A great analogy is to think of it like your desk. It's the workspace for everything you're actively working on right now.
But RAM has one really important feature. It's what we call volatile, or ephemeral. As this quote points out, the second you turn off the power to your computer, that entire workspace gets wiped clean. Poof. Everything that was in RAM is just gone. It's temporary by design, built for pure speed, not for keeping things safe. And that's exactly why we need another kind of memory.
This little table sums it all up perfectly. On one hand, you have RAM. That's your short-term, volatile memory. Data's gone when the power's off. On the other hand, you have your hard drive. That's your long-term, persistent storage. It's way slower than RAM for sure, but it's where your files, your photos, your programs, all that stuff lives safely, ready for the next time you turn your computer on.
So we've had a good look inside a single computer. But let's be real. The real magic happens when they start talking to each other. So for our last section, let's explore how that communication works using a really fundamental idea called the client-server model. Now, for a computer to talk to the great big outside world, it needs a special piece of hardware, a network card. This is basically its mouth and ears. It's the part that lets your computer physically plug into a network, either with a cable or over Wi-Fi, and actually start a conversation with another computer.
And at its very core, that conversation is incredibly simple. It's really just a two-step dance. One computer sends a request for something. It might say, hey, give me the web page for google.com. Then the other computer sends a response. It says, sure, here's all the data for that web page. Request, response. That's it. That simple little pattern is underneath almost everything you do online. And this request-response pattern has a formal name. It's called the client-server model. And listen, this isn't just some random technical detail. This is the fundamental architecture for nearly every modern application out there, from websites to phone apps to the entire cloud. Understanding this is absolutely key.
So let's break down those two roles. The client is your device, your laptop, your phone, whatever. It's the one making the request. The server is a powerful computer somewhere else that's just listening for those requests, and its job is to serve up the data or the service that was asked for. The client asks, and the server provides. It's that straightforward.
And you use clients constantly, probably without even thinking about it. Your web browser is a client. When you type in a web address, it requests that page from a server. The apps on your phone, they're clients, always asking service for new data. Even your email program is a client, requesting your latest messages.
And on the other side of that conversation, what are those servers doing? Well, they're the heavy lifters of the internet. They're busy hosting the websites you visit, storing the files you keep in the cloud, managing gigantic databases, and of course, sending all those emails around the world. They're always on, just waiting to respond to requests from clients like yours.
And there you have it. From the CPU's fetch-execute cycle to the difference between RAM and a hard drive, all the way to the client-server model that powers the entire web. These are the absolute, foundational building blocks of information technology. So now you have them. The only question is, what will you build with them?